Okay. Today we are going to discuss about how to create hierarchies. So in the previous session, we have covered the hierarchies and usage of some of the other calculation fields. And in Tableau, we will have dimensions and measures. And there are blue pills and green pills in Tableau. So today we are going to see what are blue pills and what are green pills and what is continuous and discrete. So today we are going to discuss about that. So let's get started. So Zaid, do you remember about hierarchies? So what does a hierarchies does? Hierarchies. No, let me explain. Okay, so hierarchy is basically there will be many types of hierarchies will be there. So if you say country, in countries you will have state, district, city. In cities you will have postal codes. So this is one kind of hierarchy. In country you will have states. In states you will have districts. So it will split into different hierarchies. So now let's see. In location, I have, so this is the hierarchy that has been already being created. So that is, this is what is hierarchy. So it is denoted with this symbol. So under country, you see regions and all. So let me just draw it and show. So it will be like if this is a country. So under country, you will have regions. So countries will be split into regions. And let me take regions will be split into states. So this is country. And these are regions. All these are regions. Let's assume APAC, EMEA, North America, like this. Okay, so in APAC, we will have states like, or you can take, so let's country, let's take, so let's take country names. Sorry, states. So states, you can consider Karnataka. And here you can say Telangana or something. Okay, and here it will be split into different, so in states, you'll have cities. So this will be split into cities. So what are the cities in Telangana? There will be like Hyderabad and all. Those will be under this. So like this, you will have the hierarchies. So how we can show that in Tableau is, so if I drag country here, so what are the countries we can see? So Canada and United States. And if I click on this expand button, so I should be able to see all the regions in that particular country. And if I expand more, I should be able to see in that particular region, what are the states are available. In states, what are the cities are available. And if I want to extend more, I will be able to see this. So I can do drill down. So one thing I can do is drill down. So starting from country to postal code. So that is called as drill down. So till the end, you are able to see the postal code. And if you click on this collapse button, so it is doing a drill up. So this process is called as drill up. Okay, so the reverse process going back from postal code to country is called as drill up. So this is hierarchy. So I'll just show you so how to create a hierarchy in Tableau. So for that, what I will do is I will remove from hierarchy first of all. So this is already been created in Tableau. So I'll just remove this from hierarchy. Okay, so if you remove this from hierarchy, these are individual fields. Country, city, region, postal code, all these are individual fields. Now when you drag this, you won't see that button. That expand collapse button will not be visible. So expand collapse button will be visible only when you make it as hierarchy. So now let's see how to create this hierarchy in Tableau. So just right click on that particular dimension, go to hierarchy and create hierarchy. If there is an existing hierarchy, so you can, if you want to add it to existing hierarchy, you can add. But here I want to create a new hierarchy. So I'll create the hierarchy folder name as location. So location, one folder will be created. So this is what is that folder. And it will be denoted with this symbol. So the symbol will be like this. It will be, so this is hierarchy. So it will be symbol like this. So when you see this symbol, that means a hierarchy is created. So here you can see that. So if you see this symbol, that means this is a hierarchy model. Okay, and the fields in this folder, you can use it for doing drill downs and drill ups. So now let me add the other columns into this. So there are many ways you can add other columns to this. So let me just select region. So right click on this, go to create, go to hierarchy. So now I don't want to create a new one. So if I want to create a new one, I will click on create hierarchy, but I want to add it to the location one only. Okay, so I want to add it to this location. So I'll go create, add to hierarchy. I want to add it to the location. Okay, so I have added it to the location. Next one is state. Okay, state, I will add it to the location again. Okay, so like this I can add, or otherwise I can directly select the field. So after state, I want to add city. Okay, so I'll just drag and drop it here. So that will be added to this group. And one more thing is postal code. So postal code, yeah, here. So I can just drag and drop it here. Okay, so now I can use this fields as a hierarchy. So now I will get this collapse button. So there are in two places we can see this. So this is at a developer level. So whatever you see is this rows shelf, column shelf, pages shelf, filter shelf, and mark shelf will only be visible to the developers. Only this space, what you see, this space will be visible to the users. So even user can expand these things. And what it will do. So let's say sales. So if I put sales over here, so I can see Canada value and United States value. And so I can see the split of the regions. So 22,97,000 is the value for United States. How it is splitting across all the regions. So 27 lakh is splitting for these regions. And if you click more, same 27 lakhs, it is splitting into different states, different regions. So that's how you can drill down till the postal code. Yeah. So this is about hierarchy. So any questions on hierarchy before we move to the other concept? Okay. So let's move on to dimensions and measures. Okay. So if you observe in this data pane that you see here, so all the dimensions, these are called logos or icons. So all these logos or icons are in blue in color. Why this is blue in color is it represents a dimension. In data pane, in data pane, so the icons color is blue to represent dimensions. Okay, so if you observe, date is a dimension, segment is a dimension, profit bin is a dimension, order ID, order date, all is a dimension, and these are in blue in color. And if you observe discount, profit, quantity, sales, all these are in green in color. Okay, even if you hover on that also, so it is getting highlighted with the green color. And when you hover on dimension, you can see blue color. So I'll just take this. So when you select or anything, it is representing with a blue and green color. Okay, so this is at data pane level. So in data pane level, dimensions will be represented in blue color and measures will be represented in green color. So only the icons will be colored on that. But when you select, you can see the green color for measures and blue color for dimensions. And let's see. And now let me drag this particular customer name into row shelf. Okay, now if you observe, we have this is called a pill. So this customer name, the what you see in blue color, this is called as pill and this is called as blue pill. And why it is blue in color? Usually dimensions will be blue in color. Most of the dimensions, or you can say apart from date, date dimension, all dimensions are blue in color. See, take any dimension, region you take, it will be in blue in color. I mean the pill, this pill color will be in blue color. If I take city also, it will be in blue color. So these are blue pill dimensions. Now I will show you green pill dimensions. So this is for just for our reference to understand the difference between continuous and discrete. So I will tell you about continuous and discrete as well. So now let's take order date. Order date can be in blue color and it can also be in green color. So we can convert it to, so it's basically it is in discrete mode. So whatever is in discrete mode will be in blue color. Discrete will be in blue in color. Continuous will be green in color. So this is what is the main agenda. I mean, apart from date dimension, all the dimensions are blue in color. Only date dimension can have blue and green. So I'll just write for dimension. So I'll write for discrete dimensions. All the dimensions except date or you can say, yeah, except date. Date dimension can be in discrete or continuous mode. So I will show you one classic example of order date. So I'll just take control, select this. So now I have blue one and one more blue one. So now I'll make it as continuous mode. So I'll make it as continuous mode. So now you can see this is discrete and this is continuous. And what is the difference between discrete and continuous? Here also I'm able to see years data. Here also I'm able to see years data. But the only difference is here I got axis. Okay, so I'm able to see axis. So this is what is continuous mode. So in discrete, what you will see is you will not see the axis. You will just see the discrete numbers, individual numbers you will be able to see. But when I convert into continuous mode, I should be able to see the continuous mode. I mean, continuous data. So it's like a flow. So it will show you the flow of the data. So in discrete mode, it will just show you the individual numbers. So for only date, we can convert into continuous mode. So why? Because date only has the concept of like a flow. So you can see the trend charts and all. It's because of date. For other dimensions, you don't have that option. So for other dimensions, we cannot make it as green pills. Only date dimension, we can make it as green pill dimensions. So now let's make this as continuous mode. So in continuous mode, we will have axis. So now let's talk about green pill measures. Take any dimension, take any measure. So that will be by default will be in continuous mode. Okay, so that will be in green color. So as we discussed earlier, every dimension that is continuous or every measure that is continuous will be in green color. So basically continuous will be in green in color, discrete will be in blue in color. So now this is in continuous mode. So take any measure. Now let's take sales. So that will be continuous mode only and it will be in green in color. Take orders count. That will also be in green in color. Okay, now let's see blue pill measures. So let's take same measures. Okay, so by default it will be green in color. We can change it to discrete mode and convert it to blue pill. So what it will show the individual number. So if you observe the difference between these two, so as I mentioned earlier, so you should be able to see the axis. So whenever you make measure as a continuous mode, not even in the dimension. So if I make it as continuous mode, so I am able to see the axis. So for measures also, if it is in continuous mode, you should be able to see axis. For this, you are able to see the individual value of that particular number. So now if I take sales, okay, by default it is coming with an axis. But if I change it to discrete mode, I should be able to see that individual number what it is there. Same for count of orders. So basically for measures, it will try to give the continuous mode. We can convert later into discrete mode. So what is the use of this continuous mode? So whenever you want to do some graphical charts or visualizations based on bar chart or line chart, so then you need axis. So if you have this in continuous mode, then only you should be able to create these type of graphs where you can see, let's say $500,000 is the value. So based on the axis, this length of the bar is coming. Okay, if you don't have this in continuous mode, so this is in continuous mode, measure in continuous mode. And let me make a duplicate of this one. Okay, so I just clicked on this. So this will make a duplicate. Otherwise, you can right click on and you can click on duplicate. So now I'll make this as a discrete. What will happen? So it is showing me the individual numbers, which is not what I am looking for, as I was looking only for the graphical representation or the bar chart. Okay, with this discrete mode, I will not be able to do that. So only when I have axis, this axis should be there. To get that axis, we should have to have it in continuous mode. So that is about blue pill dimensions, green pill dimensions, and green pill measures and blue pill measures. So when you connect to any data source, Tableau assigns each field in the data source to either the dimension area or the measures. So basically, Tableau will understand all the dimensions and measures, and it will segregate it like this. So all these are dimensions. You can see these are colored in blue color. So whenever I'm selecting, you are able to see the blue color only. Okay, but when you go and select this measures, so it is coming in green color. That means you can, Tableau is identifying what is dimension and what is measured. Okay, so that is one kind of representation for the developers only. This is for our reference. And blue pill dimension. So when you drag these fields to the row shelf or column shelf or to the marks cards, so that will be blue or green color. So that is dependent on whether it is in discrete mode or in continuous mode. So blue represents discrete mode, blue represents discrete mode, and green represents continuous mode. So in dimension also we can have discrete mode. So in dimension we can have discrete and continuous, but only one dimension. Date dimension only can have discrete and continuous. Other dimension cannot have discrete and continuous. So for green pill dimension, I have taken only the example of date dimension. And if you go to the measures, so in measures, it can be in discrete mode and it can be in continuous mode. So this measures can be blue or green. All measures can be blue or green. So blue color represents discrete values, green color represents continuous. So continuous is to have this axis. So to show the flow, we use continuous mode. So to create these type of charts, we use continuous mode. Yeah. So blue versus green fields. So we can have green measures and green dimensions. We can have blue measures and blue dimensions. Yeah. So only one dimension can be used as a discrete and continuous. That dimension is called date dimension. Other than that, no other dimension can be converted as a continuous mode. Yeah. Zaid, can you tell me what does blue represent? What about green? Uh, Yeah, Kishore, can you try tell me about discrete and continuous? In which color it will be? Mm-hmm. It's other way around. Discrete will be blue. Discrete will be blue and continuous will be in green in color. Yeah, dimensions can also be discrete. Dimensions can also be continuous. And measures can also be discrete. Measures can also be continuous. depending on our requirement, we can modify that. So this is in continuous mode. This, yeah, depending on. So in this case, I want to see the bar chart. So if I have it in continuous mode, then only I should be able to see this bar chart. If I make it as discrete mode, it won't work. There are some cases when you want to see data in tabular mode. This then you can use, yeah. So here it makes sense. You can convert it as discrete and you can show the values. Okay, so here it makes sense. But when you want to show as a bar chart or line chart, then it doesn't make any sense. Yeah. In this scenario, if you want to make it as a bar chart, so then you need to convert it as a continuous mode. And in dimensions, only this date dimension can be made as discrete or continuous. So with continuous, you should be able to see this axis, and without continuous, you just see the individual numbers. Yeah, so that is about continuous and discrete. Any questions, or shall we move to the next concept? Yeah. Okay, so we'll continue with the functions. So functions in tab. So there are many types of functions which are available. So number functions, string functions, date function, type conversion, logical functions, so and aggregate functions. So we'll see one by one. So number functions will allow us to compute different data values, and we can change the data types that are that is coming from the data source. So now let's see. So I'll take subcategory dimension and profit. So here I have the negative values and positive values. Okay, in some cases, let's say if I want to make this as a bar chart and I want to see like this, and I will write a calculation to represent the positive values and the negative values, or I can just drag and drop sum of profit into the color marks part. So just control select and drop it in the color marks card. And you will see this is called as color legend towards your right, right top. So this is called color legend. Here I will select two stepped colors so that I want to see for positive, I want to see one color, and negative, I want to see one color. So that is why I'm selecting only two colors, and I will select red and green. Say okay. So positive values will be in green in color and negative values will be in red in color. Okay, so here what I'm trying to show is, so I'm able to see this positive values and the negative values. So I got a requirement where I want to show the value. Anyways, it is so towards my right side, all the bars are positive. Towards left side, whatever is there, which are in red color, are my negative values or negative profit. So anyways, I'm representing that with color, and by the right side and left side, I'm able to represent. And I don't want to show this sign. The negative sign I don't want to show. So for that, what I will write is, I will write a calculation, ABS sum of profit. So which will not consider the sign of the value. So it will just show the value. So I'm just using, so instead of this value, so I will use ABS and I will put it in the label. Okay, so I'm just showing the number. So I have the previous bar chart as well. So in this chart, I'm showing whichever the bars are in green are positive profit, whichever is in red in color is negative profit. and I'm representing with a negative sign as well. But I got a requirement saying need to remove the signs. So what I have written, I have written an absolute calculation where it is removing the sign. Even if it is positive or negative, uh, just show me the value. Anyways, I'm representing what is what is profitable and what is non-profitable. I'm just representing it with the color, so I don't want to represent with the sign again. Okay, so that is the requirement. So for that, I'm using a calculation called ABS. And now let's go to the other functions. Okay, ceiling. So it is a combination of, so let me just open an Excel. So mathematical rounding. And we also have ceiling function and floor function. We'll say actual number. So I have an actual number 52.69. Okay, so let's say, yeah. So I want to round it off to, so I don't want to see any decimals. So what will be the mathematical rounding for this number? Zaid, can you tell me what is the mathematical rounding for this number? Without decimals, I want the number. Yeah, it is 53. Perfect. Okay, so in ceiling, what it does is, so it will take the highest integer. So I'll just tell you can be. So it can be 52 or 53. So in ceiling function, so according to mathematical calculation, it is 53. But in ceiling function also, it will be 53. It will consider the highest integer. It will consider the highest integer. I'll give you one example so that you will understand. So this will consider lowest integer. So in this case, both are correct. 50, here also it is 53. And for floor function, this is not 53. It will take the lowest integer. So what is the lowest integer? 52. So there are some kind of requirements that you get where you need to do the round off, not based on the mathematical calculation, where you need to do round off according to the requirement. So you should every time you should not consider the highest integer or lowest integer. So that is dependent on the how you get the requirement. So now I'll take one more example like 52.3235. So what is the mathematical rounding? Kishore, can you tell me what is the mathematical rounding for this? 52. Perfect. Okay. Zayed, can you try for ceiling? What is the value for ceiling? Hello? Yeah, so it will take the highest integer and floor will be 52 as it will take the lowest integer. Yeah. So this is how it does the rounding off. So now let's see. So I'll take sales. And I'll take country. So let me show the two decimals. So to show the two decimals, so I'm just right clicking on this measure click on format, click on the numbers, select number custom, and here you can select how many number of decimals that you want to see. I want to see 2. So this is how I can see. And I'll make this as a duplicate. Okay, so mathematically, if you do a round off for this one, so it will show you. So for this, it will be 201. And for this, it will be 33 only. Mathematically, 201 and 33 you will get. But I want to see according to ceiling function. Ceiling of sum of sales. Remove this and put this. Okay, so according to this, it has to it actually has to be 29,333.333 only. So if I do remove this decimals, it is actually 29,333. But it is giving me extra number. It's because it is rounding off to the highest integer. And in case of this one, it is giving us the exact value. Why? Because in any ways, rounding off is also taking the highest integer, and in ceiling also will get highest integer. So that way this matches. So this is about ceiling. And now let's see floor. Take select sales and let's take country. Yeah. So instead of this, I will write floor function. Floor of sum of sales. So I'll use this floor of sum of sales. Okay, so basically the actual number is, so when you do round off, so this will be anyways the lowest integer, 29,333. So this will anyways match. And in case of this one, so mathematically it will be 201. So if you do mathematically, when I reduce the decimals, it is actually 201. But I have used floor function, so I can see the lowest integer. So that is what is the concept here. So I'll take one more example here, 56.4, and I'll also take 64.8. Yeah. Zaid, can you tell me the mathematical rounding for this? 56. Ceiling? Perfect. Floor? Yeah, perfect. Yeah, Kishore, can you tell me the mathematical rounding for this? 65, perfect. Ceiling? Yeah. Floor? Perfect. Yeah, Tabasum, can you tell me for this one? What is the mathematical rounding for 35.25? Yeah. Ceiling? Perfect. Floor? Yeah. So for floor, it will take the lowest integer. Perfect. So that is about ceiling and floor. So that is how Tableau also will calculate. So now let's move on to the next functions. So div will find out the division of two different measures or two different numbers. So now I want to calculate profit margin. Profit margin. So like this, I can create KPIs basically. So KPI is nothing but key performance indicator. Key performance indicator, which will tell me about how my business is performing. So based on that, we can identify the business performance. So if you take an example of sales or profit, so this can be called as KPI. Why? Because if my profit is increasing, so I can say that my business is performing good. If my profit is decreasing, I can say that my business is performing very low. So with that, I'm able to decide how my business is performing. So that is why we call these type of measures as KPIs. And in real time, we will define KPIs. Define KPI meaning, so you will be getting a formula to create KPIs. So I'm going to show you one small calculation how we can create a KPI. So I'll just write div of. So the profit margin is one more KPI I'm going to create. So I just want to divide sum of sales or sum of profit divided by sum of profit divided by sum of sales. So this has to be an integer. So let's put it as int. Okay. So now I'm calculating profit divided by sales. So say okay. So I'll just put sales first. Sales profit. So let's calculate for region. I want to see in the text mode. Yeah. So sales is there, profit is there. I'm just trying to calculate my profit margin. So I'm just trying to divide sum of profit with sum of sales. So I'll use that calculation, profit margin. So this is coming as zeros. Actually, so when I'm dividing smaller number with the bigger number. So that is why it will be in 0 dot something. So it is rounding up and it is showing you 0. So convert it as a percentage. So right click on this, click on format, click on percentage. So let's write it as edit. You can just write sum of profit divided by sum of sales. Say okay. Yeah. So this way we can see the profit margin. And now let's talk about this div calculation. So div calculation, whenever you want to find division of two values, let's say 5 divided by 4 or let's say 20. If you want to find out this value, so click on this, say okay, div, edit this, do other way around, 20, comma 4. Okay, it will show the division. So basically what it is doing is 20 divided by 4, which will be 5. So this you can create or this you can use while writing calculations. Yeah, so this way you can write the div calculation. And when you want to write some calculations using sum of profit or sum of sales, so you can directly use the mathematical calculations. You can directly do sum of profit divided by sum of sales. And now let's go to the other functions. So these are the exponential functions. So if you want to find out the value of exponential of 2, so this is also when you want to create some KPI calculation. So you might get some requirements to multiply with the exponential of 2 or something like this. So then you can use this mathematical function. Say okay. Double click on this. So you should be able to see what is the exponential of 2 value and what is the exponential of 3 value. Say apply. So this way you can use these values directly in the calculation. So floor we have already discussed. And now let's talk about max. So to discuss about max, so I'll just take sales and the profit. Profit subcategory. So here I can see these values and I want to find out which is the maximum value in these two. So what I will do is I will write a calculation max of sum of profit, sum of sales, max value. So I can just use this max value. So it will compare these two values and whichever is the max value, sorry, these two values, profit and sales. So what is the highest value in these two? Zaid, what is the highest, what is the maximum value when you compare this profit and this sales? Kishore, can you try? Am I audible? Okay. Can you try which is the maximum value in these two? In these two, what is the maximum value? Yeah. So by using this max calculation, we can find out what is the maximum value in this two. Let's say in this, it is 1,08,213. So like that for each and every row. So it will compare profit and sales and it will give you this value. In the same way, we can find out minimum value as well. So you can just modify this existing calculation and change max to min. So say okay. So now it will compare same these two values and it will show you the minimum value. So like that you can compare and you can get the minimum values. So not only that, so let's just see if I use instead of this profit, sum of profit, I can just use maximum. So I can write it as max of profit. Okay, so what this is giving is instead of doing the sum for accessories, so I have this particular data. So let me download this into CSV. Downloads, accessories. So I'm opening that file in Excel file. So I just want to see how this max is getting calculated. So basically when I do sum, so I will just remove all this. Let's take sales. So basically, when I try to do the sum of sales, so what Tableau is doing is, so it is just filtering on subcategory. So let's search for subcategory. Yeah, search subcategory. And it will select accessories. So now accessories getting got selected. So if you see, all the rows are accessories. All these rows are accessories only. And what it will do is, it will take the sum of all these rows. So what is the sum? It is 1,67,380. So now let's just go to the Tableau and compare. So it is 1,67,380. So that is how it is calculating the sum. And now when let me do a max. So instead of sum, if I use aggregation as max. Okay, so now it is giving me a different number. Earlier I have 1,63,000, some value is there. But now it is giving me 3,347. But how that value is coming? So if you see, from from all these rows, it is trying to find out the maximum value. So now let's sort it. Go to data, click on this sort, expand the selection. So I want to sort this value smallest to largest. Okay, say okay. So now go to the bottom. So if you see, so this is sorted based on the ascending order. So at the end you see 3347. So that is the maximum value in the entire records of accessories. So that is the value it is showing. And so same, I mean, it is same for all the subcategories. Appliances, art, binders, whatever is the maximum value in all those rows, it will pick that value. And when I make this as minimum, so if I make this as minimum, what is the minimum for accessories? So let's go to this Excel. So let's go to top. 0.99 is the minimum value. So this is what is minimum value. And below this is maximum value. So let's check in Tableau whether we have 0.99. 0.99 we can see. This is the minimum value. So that is the importance of minimum and maximum in Tableau. Yeah, so that is how we can use. So sales and profit. So even the names also we can consider, even the dimensions also, but that's not most used. Why? Because we will just find out based on the ASCII value. It will just find out which name is the highest name. And now let's discuss about power. So power is also a normal mathematical calculation. So let's create a calculation called power. Power of 5 comma 2. So it is nothing but 5 to the power of 2. So the value of 5 to the power of 2 is nothing but 25. So now let's see whether this shows 25 or not. Okay, it will show 25. Okay, so that is how you can represent it. And if I want to see pi to the power of 3, say apply. And if you want to see 10 to the power of 3, like that, you can create the power. So I will publish this to the Tableau public. So just try. So you guys also try to do this things, these calculations and everything. Try to do it in your desktop and publish in the Tableau public. Okay, anyways, I need to check this password and all. So once I publish, I will share the link in the group. Okay, try to replicate whatever I have done today. So this blue pill measures in continuous mode, all these sheets, try to replicate. And I will also share the today's video and this Tableau public link in the group. So try to replicate this and share the work in the Tableau group. Any questions? Okay, yeah. Okay, then let's continue tomorrow. Thank you all for joining.